Welcome. I am Ms.R.Devi, Lecturer and Head Department of Computer Science, Sitarashmi Ramaswamy College, Tiruchirappalli. Now we can see the e-content of programming models for cloud computing. Programming model is a specific way or a method to approach that is followed for programming, each having their own advantages and disadvantages. One programming model cannot be the solution for all the problems, even with a large number of advancements. In these cases, a whole new programming model is developed for a specific set of problems or for general use. As a technology, cloud is considered to be good and is popular because it allows users to primarily use computing, storage, and networking services on demand without spending for infrastructure. The service architecture of cloud has three basic components called service models, namely infrastructure as a service, IaaS, platform as a service, PaaS, and software as a service, SaaS. Among these three, SaaS, which is the most important model where software is given as a service from cloud. There are generally two types of practices. One is extending the existing program models or languages to cloud. The other is to have a completely new model specifically designed for cloud. Next, we see about the extended programming models for cloud. Scalability is the ability of the system to scale itself up or down according to the number of users. This is one of the reasons behind the popularity of cloud. Thus, this property should be taken care of by any programming model. First, we see about MapReduce. MapReduce is a parallel programming model developed by Google. MapReduce uses a parallel programming paradigm for computation of a large amount of data by partitioning or segregating them into several pieces, processing them in parallel, and then combining them to generate a single result. These processes are called map and reduce respectively. The first step in the map and reduce functions involves segregation of large data and sending it to map function. The map function performs map operation on data. Subsequently, the data is sent for reduce operation where the actual results are obtained. Next, we see how the mapping is done, which is done by map function. First, the large data are traced and segregated as key value pairs. The map function accepts the key value pair and returns an intermediate key value pair. Usually, a map function works on a single document. The following formula depicts the exact operation. Map of key 1, value 1 with list of key 2, value 2. The list of key value pair obtained is subsequently sent to the reduce function. Next, we see about the reduce function. Once a list of key value pair is prepared, after the map functions, a sort and merge operation is applied on these key value pairs. Usually, reduce function works on a single word. Input of distinct key value pair is given, and in return, the group with the same key value pair is obtained as shown in the following equation. Reduce of key 2, list of value 2 with list of value 3. The resultant values give the final set of result. Example for map reduce. The most popular example is counting the words in a file. In the first step, the words which is a key are assigned the values. The word represents the key and the count represents the value. Whenever the word is encountered, the key value pair is generated. This set of word count pair obtained from the map function is sent to the reduce function. The result is sorted and the reduce function combines all the words that have the same key. The count, which is a value, is automatically incremented or added for each pair obtained. Thus, the result gives each word with this count. The example for the map reduce. In the input, this is an apple. Apple is red in color. In the input split, this sentence is divided into two subsets, which is this is an apple. Second is apple is red in color. From this input set, we map it. We count the number of characters, which is this is repeated once, is repeated once, and is repeated once, apple is repeated once. In the second set, apple is repeated once, is repeated once, red is repeated once, in is repeated once, and color is repeated once. Then a shuffling is made in which we see that in the whole sentence, in the two sentences given, this is repeated once, is repeated twice, and is repeated once, apple is repeated twice, red is repeated once, in is repeated once, and color is repeated once. Then the reducing is done. Last, the output is this is repeated once, in is repeated twice, and is repeated once, apple is repeated twice, red is repeated once, it is present once, and color is present once. Next we see about CGL map reduce. CGL map reduce is another type of mass reduced runtime and was developed by Ignite. CGL map reduce uses streaming instead of a file system for all communications. This eliminates the overheads associated with file communication, and the intermediate results from the map functions are directly sent. This is the CGL map reduce diagram in which you have a network which is a content dissemination network, and we have a map reduce function, an MR driver, a user program. In this map reduce function, the data are split. Next we have the data read write, and we have the file system. The CGL map reduce, the map worker is responsible for doing map operation. The reduce worker is responsible for doing reduce operations. The content dissemination network handles all the communications between the components using the Narada broker. MR driver is a master worker and controls the other workers based on the instructions by the user program. Several steps involved in the CGL map reduce are: first is the initialization stage. The first step involves starting the map reduce worker nodes and configuration of the map reduce task. Configuration of the map reduce is an one-time process and multiple copies of it can be reused. These configured map reduce are stored and executed upon the request of the user, and fixed data are given as input. Next is the map stage. After the initialization step, MR driver starts a map computation upon the instruction of the programmer. This is done by passing the variable data to the map task. This is relayed to workers for invoking configured map tasks. The map tasks are transferred directly to reduce workers using dissemination network. Next is the reduce stage. As soon as all the map tasks are completed, they are transferred to reduce workers, and these workers start executing tasks after they are initialized by the MR driver. Output of the reduce function is directly sent to the user application. Next is the combined stage. In this stage, all the results obtained in the reduce stage are combined. There are two ways of doing it. First, if it is a single pass map reduce computation, then the results are directly combined. And if it is an iterative operation, then appropriate combination is obtained such that the iteration continues successfully. Next is the termination stage. This is the final stage, and the user program gives a command for termination. At this stage, all the workers are terminated. Thank you.